Yo, what's going on, guys? Today's video is going to be pretty different. This is going to be episode 5 of the multitask saga as far as my YouTube channel is concerned. But this video is really for the completion of a project at school. And I can't send it in because the file size is too large. So what I'm going to do is make it a part of the YouTube channel so y'all can enjoy me doing some schoolwork assignments and stuff. And yeah, and I can get a grade at the same time. Two birds with one stone. You know? But yeah, this assignment was about describing how a natural event on a widespread level can affect the environment. And I basically describe in different forms, you know, how it affects the lithosphere, the atmosphere, the different parts of the biosphere, and how those different parts of the biosphere, you know, hydrosphere, stuff like that. And the cryosphere, which is ice. So yeah. I don't want to bug y'all too much with the talking because there's a lot of talking in this video already. But yeah, if you sit through it and you're a nerd like me, like you enjoy stuff like this, and let me know how I did. But without further ado, let's get started. Greetings, all members of national security as well as the general population. My name is Dr. Wizzlebottle, and today I'll be discussing with you an event that is unlikely to happen, but whose chances are never zero. The event in question being an asteroid striking our Earth. I believe that as we are now, we are unprepared not only to prevent this from happening, but to deal with the consequences thereof afterwards. A group of scientists at Los Alamos National Lab have researched the direct physical impact of an asteroid hitting the ocean. We'll be talking about their findings of the simulation of a non-airburst asteroid striking the ocean no further than 200 miles away from the shorelines. For those who don't know what a non-airburst asteroid is, a non-airburst asteroid is an asteroid that does not explode on impact or before impact with the environment. First, we will talk about how it will affect the hydrospheric portion of the biosphere. As you can imagine, the asteroid will be extremely hot, so it will incapacitate and kill every fish within the area. Deep water fish are more likely to be safe, but anything near the surface in the area will be incapacitated or killed. Now, due to the nature of this impact, tsunamis are likely to occur. This means that anything in shallow water or on the coastlines will be washed inland and killed. This includes sea plants, fish, crustaceans, and more. Now we will talk about how it affects the lithosphere portion of the biosphere. Any living beings, including humans, animals, plants, and such, will be incapacitated or killed by the upcoming tsunamis. The size of the tsunami is also expected to be affected by the mass of the asteroid. If you have an asteroid that's even 3 miles wide and strikes in the Atlantic Ocean, it will spawn tsunamis that will reach all the way to the inner mountains of the United States. However, a smaller asteroid, maybe a couple of kilometers in diameter, will cause a tsunami in proportion to the water caused by a hurricane. Now we will talk about how it affects the atmospheric portion of the biosphere. In this simulation, the asteroid striking the ocean will cause an immediate evaporation of millions of gallons of water. Now, as far as direct consequences go, this will minorly affect the atmospheric portion of the biosphere. Any birds within the area will be incapacitated or killed by the steam uprising from the asteroid or the impact of the asteroid itself. But as far as long-term consequences, being that water vapor is a greenhouse gas among CO2, CH4, N2O, and others, this would have a negative effect on our already worsening environment. That is, if the water vapor reaches up to the stratosphere. Long-term consequences like the speed of the Antarctic ice melting are going to be affected. Any water that doesn't make it as high as the stratosphere would have a temporary effect on the water cycle. The instantly made water vapor, along with any water evaporated from the tsunami strike inland, will cause rain cloud formations and precipitation that was not expected before on your forecast. All in all, I hope that this information brings forth the awareness of the seriousness of this event happening. Although, as I said, that is not likely to happen, the chances of it happening are never zero, and the consequences are extreme. So I hope that we all can get together and find a solution for this problem before it starts.